just after that, Tanya will present you a bit more about SGSE.
So, hi everybody. So I'm Tanya. I'm the event manager of SG France 2021, and as Antoine said, I'm going to talk to you a little bit more about SGAC in the world and SGAC in France, and about the event. So SGAC is basically a big network of space geek and space enthusiasts all around the world. So we are today more than 15,000 members on all the planets, and it's a very great opportunity to meet people that have the same passion as you, and you can have many great opportunities thanks to SGAC. So if you go on the next slide, we can see the different activities that SGAC proposes. Yeah, you can have some different type of events every time a year everywhere in the world again. So you have the main event, which are the SGFF and the SGC, which is taking place next to the IAC each year, the International Astronautical Congress, and it's the big event of the year where most of the SGAC members meet. But you can have also some more local events like SG France, SG Germany, SG Spain, etc. in Europe, but also in the other countries. You can also work on some project groups. Today there are 11 project groups, I think, so it can be whatever you want. There is some space law groups, there are some space medicine, space exploration, gender equality groups, etc. So many different activities that you can do here with SGAC. You can obviously enhance your professional network and get some scholarship from this to attend some space studies or to attend some events where you will be able to share your passion. And finally, you have some United Nations related activities, because SGAC main goal is to show the voice of space generation to the United Nations, and to represent, yes, this young generation and the opinion of that we have on space questions. So next slide, please. And I'm going to talk to you a bit more about SGAC in France. So today we have a growing community of 230 members. And it's also a great opportunity to meet French people that are passionate about space. And so this year is going to be the third edition of SG France, because there were two previous editions in Paris, in Toulouse last year, and this year is going to be in Lille. We have two very nice point of contact, which are Pauline Delande and Guillaume Thierillon, that you can contact for any SGAC questions, related questions. So on next slide, we can talk more about our event that is going to take place next week, actually. So it's very close from today. So it's going to tackle the question of the synergies between space and non-space sectors, and how to bring more space in our daily life and find more collaboration between this beautiful field of space and the non-space activities. So it's going to take place next week. It's going to be all day during the Saturday, and it's going to be in Centrale Lille, which is an engineering school in Lille. And we have been tackling the three different topics during our three last webinars. And today we're going to tackle the topic of our last roundtable, which is about non-space sectors collaboration with lunar exploration. So this is all. And a final slide concerning the other event, which is going to take place on the day after SG France, which is the Summer Space Festival, and Antoine is here to talk about it a bit more than me, but it's going to be as well another space event taking place at the same place just the day after. So you have another great reason to come to Lille, and you're going to be able to talk and talk with the sponsors and the different speakers that are going to be there. So it's a free, and you can attend it online as well, but it's better if you go on site. And you will be able to exchange with some people from university, from association, and from sponsors and companies that are going to come on the event. So now I think I'm done, and I'm going to leave the floor to our wonderful speaker we have today to tackle this great question of lunar exploration benefits.
Thank you very much, Tanya, and thank you for the presentation of SGAC. Just before we get started, we had prepared a small Slido for you, just to get to know a bit more each other and know where you're coming from. So we would recommend in the chat, you should find the link to Slido, which is this website where you just have to enter a code, which is in the chat. And we have a few questions to get to know a bit more better which audience we have today. So I will jump to the window, and then we'll have a first question, which is, where are you coming from or to attend this webinar? Roubaix, interesting, close to Lille. Okay, nice. So the next question we have for you is, are you actually coming to this SG France event in Lille in 10 days? Will we have the chance to meet you? What they are doing and what they want to show you as well. Another question now, what is your field? Are you working, studying, in which field? So systems engineer, aerospace engineer. Do we only have technical people here, or do we have some, okay, satellites operation, electrical engineering? So as you may know, SGSE is a very big network. Many people are engineers, and I can see that here. But we also have people more on the business side, more on the legal side, scientific side as well. But so far so good, mostly engineers, which is quite good because talk today will be quite technical, for instance. But we also have, okay, space medicine, I see, entrepreneur, astrophysics, chemist, business development, awesome. And last question so far, have you ever participated before to any SGSE event in the past? Okay, great. So mostly people who don't really know about SGSE, but who have not maybe been to any event, but still know about the network. Well, we actually have this question. Would you rather go to the moon, Mars, or maybe Venus if you had any chance to? Okay, great. Thanks a lot for the participation. I'll give the floor now to the speakers. And just before that, introducing again the topic of today's webinar, we'll talk about lunar exploration synergies with non-space sectors. This is a topic that we'll discuss in Lille with three main fields: space resource utilization, robotics, and human exploration and settlement. And for that, we have a great panel of experts today, all here to show you a bit more about what they're doing. And I will let every expert introduce himself or herself, starting with Carlos Espejel.
Thanks a lot, Antoine. Can you guys hear me well?
Yep, perfect.
Excellent. All right. First of all, good afternoon, everyone, and thanks a lot to the SGAC organizers to keep putting together these really interesting and fun events. And at the same time, I invite everyone to join us in Lille on the next weekend. It's going to be a great event, and hopefully we get to see you, all of you there. Okay, I'm going to introduce myself a bit here. So my name is Carlos Espejel. I am the Space Resource Utilization Lead for Icepace. I've been working for Icepace for around almost 3 years now. But before that, I was working for the mining industry for companies as Glencore, Xstrata, BHP, Rio Tinto, and so on. So I actually come from the mining industry as a mine planning engineer. But before that, I actually started as a mining engineer. So it's been a couple of lives before joining Icepace. Okay, but I'm going to share my screen.
Well, just before sharing the screen, we just have a quick presentation of everyone, and then we will go with you, Sonia, Miguel, and Romain in the order of presentation.
Oh, perfect.
Okay.
Can you give a word?
Yeah, so good evening from my side as well. So my name is Ksenia Milicevic Neumann. I know a bit difficult always to pronounce and to read it, especially for the English-speaking people. They always pronounce it Xenija, which is really weird. So it's Ksenia. I am a senior research advisor at IME Institute. It's the process metallurgy and metal recycling at RWTH Aachen University. So before that, I did my PhD actually at the same institute in the field of electrochemistry with this background of the metallurgy in cooperation with the German Aerospace Center. And after that, worked in a startup in Luxembourg in space resources, and then got back at the institute working in different fields, space resources, battery recycling, but also zero emission metallurgy. Yeah, so that's from my side a bit of mixture, and I'm very happy to be here and with this great panel and participants, and looking forward also to see you in Lille in person. I'm really looking forward to this live events. I'm missing it. Have fun.
Thank you very much, Ksenia.
So now it's my turn. So hello, everybody. Thank you, Antonio Buquer, for organizing this, and all the guys from SGAC for the invitation. It's a pleasure to share the floor with these great panelists. Well, so I'm the head of the Space Robotics Research Group in University of Luxembourg. I'm professor of space robotics, but I was not on space all the time. So I'm a computer scientist that moved to industrial engineering for doing a master and a PhD on automation and robotics. And then I've been working with aerial robotics and ground robots for more than 15 years. Then I moved to Luxembourg like 8 years ago to start activities on aerial robotics. And since 2 years, I'm professor on space robotics and the lead of the Space Art group, and also have been constructing and setting up the piece of moon on Luxembourg, the Lunar Lab, and also an orbital robotics lab, call it the Syroge Lab. So looking forward to continue and see the presentation of everybody here, and waiting for have this event on Lille. That's as well as my previous panelists, looking for a in-person event. Yeah.
Thank you, Miguel.
Good afternoon, good evening, or good morning, everybody from the US. I think it's more the morning. My name is Romain Charles, and today I am here with you as the support officer for the spaceship FR, which is a structure that I will talk about a bit later, so I will not spoil too much about it. I am an engineer for MEDES, which is Médecine Spatiale in Toulouse. I have been for the last 8 years, first in Cologne with the European Astronaut Center, and now with the CNES in Toulouse for this spaceship FR. And I think I will stop it here because I'm too afraid I would spoil the surprise for later. So thank you for that.
Thank you very much, Romain. Thank you very much all for the introduction. And now I give the floor to Carlos to share the first presentation, space resource utilization.
Thanks a lot, Antoine. I'm gonna share my screen. Now, please let me know.
We will take all the questions at the end after the 4 presentations. Perfect.
Okay, excellent. And we have around 10 minutes, is that correct?
Exactly, 10 to 15 minutes per presentation.
Perfect. All right, you can see my screen, right?
Yes, we can see it.
Okay, thank you. All right, so I'm going to be speaking a bit about space resources utilization or SRU. I just always like to say that I know in the mining industry we call it mining, but in the space industry now we are now calling it ISRU or SRU. I really prefer to use space resource utilization. Now within Icepace, we are a lunar exploration company, and we have a vision, which is expand our planet and expand our future. Which is to expand human presence beyond Earth through the utilization of space resources. So I'm going to be sharing of a bit of what Icepace and what we're doing. And please, your questions will be more than welcome at the end of the presentations. Okay, so a bit of an agenda. I'm going to just speak really quick about Icepace. What do we do? A bit about lunar resources, just a really quick summary on that, about lunar exploration, some data analysis that we are intending and doing here in Icepace. And we would like to share some pretty exciting news from our side, which is a couple of NASA contracts, and how we're intending to do this with the terrestrial industries. Okay, so on this, in the Icepace activities, before that, I just would like to give you a really quick overview on Icepace. So Icepace is pretty much a multinational company, but the headquarters are in Tokyo. We have another big office in Luxembourg, that's where I am based, and where we are around 20 people. And we have a third office in the US in Colorado, where we have now around 30 people. So in terms of activities in the US, that's where we are designing the bigger lander. We have another smaller lander being designed in Japan, which is the one that I have on my background. This one is gonna be traveling next year in June, so 2022, and we're gonna have another of these landers traveling to the south pole of the moon in 2023. And in 2023, we will be deploying a rover, which I think is here in my background. That's going to be an exploration rover that we're going to be deploying in 2023. So, and in Luxembourg, we're pretty much focusing on the exploration technology and on the space resource utilization side of things. So pretty much space resources and exploration technology is done here in Luxembourg. Okay, so as I was saying, pretty much we have three main types of activities in Icepace, which is lunar transportation. We have a lander. Again, we're going to the moon next year, and we have an exploration rover. Right now, the rover looks quite small, but we're working on different sizes of rovers for different activities. And we also have partnership programs for the companies that are trying to get into the space industry. So for those companies that are interested in marketing and mainly getting into the space industry, we can help them on that. But one of our main targets here and activities is lunar data. What we're looking at having the capability of acquisition of data, of course, for resources, but as well for environmental purposes, imagery, entertainment, and so on. But for today, we're going to be speaking about the resources side of things. Now, not only the acquisition of data, but as well the analysis of data and then further modeling on these resources data. Okay, in terms of lunar resources, just really quick, I'm sure many of you already know, but now it's pretty exciting because now there's a lot of data that comes from the different agencies, as from NASA, ESA, JAXA, ISRO, about the distribution, well, the existence and the distribution of resources on the moon. For instance, that's a real data showing the existence of iron, and now we know that there's magnesium and aluminum and calcium and silicon related to iron. At the same time, we know there's a lot of thorium and uranium and the creep elements around it. So rare earth elements is a big thing. Now, as we know, China just pretty much recently landed on the moon, and they're not shy about it. They had a lot of scientific purposes on their mission, but one of them was to look for rare earth elements. At the same time, there's plenty of titanium, up to 11% grades on the surface. So this is on the first 2 meters of the lunar surface, which is that's pretty high grades compared to the terrestrial grades in titanium. There's lots of sodium, hydrogen, and oxygen. And of course, one of the latest discoveries is the presence of H2O. Now, at the moment, we do not completely know if it's H2O or it's just HO. So we really need to go there and confirm exactly how, in which form it is. But on this, we also now know the exact locations of where these deposits could be, and we started to model these deposits, and I will show you a bit of that in the next slide. Now, the current data is showing that there is anything from 6 to 6 and actually more, like 10 billion tons of H2O on the south and north pole of the moon. Now, why is H2O so important? Because H2O can be, well, H2O is like the holy grail. So it's not only for oxygen or oxygen for astronauts, but it can be fuel. For instance, ULA, which is United Launch Alliance, which is made by Boeing and Lockheed Martin, they already offered to pay $3,500 US per kilogram if there is a company that can sell fuel in LEO, and $500 per kilogram to any company that can sell fuel on the moon. So with this, many companies and countries got interested in this. So on that, I just want to show you that there's a lot of activity in terms of space resource utilization, not only on the states of space agencies, but as well in the private sector, so commercial missions. So on the states missions, like SRU missions, so space resource utilization missions, we have missions coming from China, like Chang'e 5, that's last year. We have Chandrayaan 3 that is supposed to fly this year, might fly next year, but this is the Indian Space Agency. We have the Lunar Ice Cube from NASA, the Lunar Polar Age Mapper from NASA, Viper, which is going to the South Pole, and it's going specifically to look for water ice or permafrost in the south pole of the moon. We have, of course, a number of Artemis missions and activities happening between 23 and 25, as we know. And then in 2025, we have the Lunar Trailblazer from NASA, and they're all looking, of course, for H2O, hydrogen, among others. Now, in terms of the commercial missions, we have companies as of ourselves, Astrobotic, Lunar Outpost, and SpaceBeat. I'm just going to share some of them. So, for instance, this year, Lunar Outpost is supposed to send M1 MAP mission as a GUMO from SpaceBeat. And next year, we are flying in June to the mid-latitudes of the moon. And that's our mission M1. And then Moon Ranger from Astrobotics is flying next year as well, and Cold Map from Lunar Outpost as well. And then in 2023, we have our second mission, which is the M2. And again, M2 is to the south pole of the moon. So for Icepace, M1 is in the mid latitudes of the moon, and M2 is in the south pole. And then we have HL map. Okay, so that was only space resource utilization missions, right? But then we also have a lot of activity going on the moon. So pretty much all the main agencies have some sort of project, activity, or mission on the moon. So the moon is kind of popular again, and there's lots happening on the moon, which is pretty exciting. And this graph on the right is showing that there is more than 60 lunar missions over the next decade. I'm just gonna let the airplane pass. And these more than 60 missions are government and commercial. So there's plenty of activity happening on the moon. All right, so, but it's not only about going there to the moon and landing there and extract resources. It's not that easy. There is plenty of work that needs to be done. There's plenty of technology that needs to be developed. And there's plenty of partnerships that we need to create between space and terrestrial companies, right? But one of the main activities and first activities that we need to do is exploration. Now I'm just gonna show you really quick what are the steps that we need to follow in exploration to get to enough geological confidence to be able to extract following mining standards. So the next graph that I'm going to show you is from LORS, the Lunar Ore Reserve Standards, is the GRCS1 chart. Now this one is just measuring geological certainty, and I'll show you how it works. So pretty much in exploration, which are the activities that we're going to use to increase geological certainty. Within exploration, we have two main types of activities, which is prospecting, which is going to be mainly using remote sensing technologies and mainly orbital work. And then we have ground truth exploration. This is actually going to the surface and getting samples. Now we have sub-activities. This is, we call it a space exploration target. So with this, it can be the prospecting or ground truth exploration. Now, an in situ exploration target is when you actually go to the surface of the moon and get a sample, but in situ. So not only from the surface, but you have to be subsurface, so pretty much drilling. So through all these activities, you will be raising your geological certainty. And in this classification system, it starts in speculative resources. So when you just do orbital work, you just pass your orbiter with your neutron spectrometer, and you find some hydrogen on it. Well, that, according to this classification system, it can only be called a speculative resources because we have a geological knowledge error around plus minus 85%. Now, the more exploration activities that you can do, you go up to prospective resources, inferred resources, all the way to measured resources. Now, just really quick here, in the mining industry, if you want to mine something commercially with enough confidence, your resource needs to be at measured resources, which means you need to do a lot of exploration work, a lot of drilling, so a lot of samples on the surface. And as the processing engineers that we have here today, we know that a big important part of exploration is geometallurgical testing. So we need to make sure that whatever we're finding, we can actually process it or separate it. So an interesting thing here is that geological discovery test line. So pretty much anything from inferred resources upwards. So pretty much once you're doing in situ sampling, you can call it that it passed the discovery test line. So with this, you have undiscovered resources that you haven't really drilled and take enough data, and then you have discovered resources. So really quick on this, Where are we as humanity in terms of resources exploration in space? We are somewhere there at the moment, because most of the data that we have is mainly orbiting data. Yes, there's some samples that our astronauts from the Apollo missions took, but it's not enough. So right now, most of our work is there, so you can see all the work that needs to be done before we start extracting. Antoine, can you please let me know how many minutes I have left?
Yes, Carlos, you have 2 minutes left.
3 minutes?
3 minutes, sorry. 3 minutes left, yes.
Okay, thanks for that. All right, so on this, I'm gonna move a bit quicker. So once you do all this exploration and you get data, now we need to analyze it and do modeling with it. In Icepace, we're doing certain activities in terms of processing and data analysis. One is mission planning. We're looking at mission planning mainly for our rovers, like traversing, so landing zones, prospecting and exploration campaigns. We're doing a lot of geological modeling for scientific and resources. We're doing resource estimation. So pretty much the quantity, quality, and distribution of these resources. Reserves estimation, which is the economical part of your resources. So it's not only, it has to be economic and technically extractable to call it a reserve. And then we are also doing modeling and optimization of the SRU value chain. So pretty much we take into account, we model everything from exploration, extraction, processing, storage, manufacturing, transport, all the way to your customer. And this is called pretty much value chain optimization or strategic mine planning. Okay, those are some of the activities that we're doing in Icepace. Now, this is just an example, some real data from the South Pole, where we took high definition topography. We grabbed some thermal page models, and we created a block model, maybe potentially one of the first or the first block model of the South Pole of the Moon using real data. And here now you can see the actual distribution of the permafrost in the South Pole. And it's a zone where we're actually planning to land. So this is a real area where we're planning to land and extract potentially those resources. Now in this other image, you can see a cross section which is showing in yellow where the permafrost could be. This is maybe at 1 meter in depth. So pretty much it's showing you the overburden or waste material that you would need to go through or remove to intersect the permafrost there. Now, using loss reporting classification system, because it's quite low resolution, we can call these prospective resources because the geological knowledge on this is plus minus 75. It's pretty much undiscovered resources because the geological knowledge is quite high. And the next step for us is to do ground truth exploration to increase the resolution or geological certainty of this. Okay, so on this, I just want to share to finish some like big news. So NASA gave 4 contracts last year to companies that can go to the moon, collect the resource, and sell it to NASA. So this potentially could be the first commercial resource transaction in history. And we are proud to mention that Icepace won 2 contracts out of the 4 contracts. So we have 2 contracts to sell, pretty much to go to the moon, collect the resource, and sell it to NASA. Now with this, we're trying to involve the terrestrial companies and space companies. So we put together a consortium, which we call the Commercial Space Resource Utilization Pioneering Team, where we are bringing the experts of the world in terms of exploration, extraction, processing, storage, technical supporting services, and financial supports. And of course, the customer in this case is NASA. But we're putting together a consortium of terrestrial companies and space companies to deliver these 2 NASA contracts, which is pretty exciting. We're actually going to the moon, collect some resources, and sell it to NASA. Okay, I'll finish the presentation here. But thanks a lot, guys. And I'll be looking forward to your questions at the end of the presentation.
Thank you very much, Carlos. Right in time. Thank you for the great and detailed presentation. We will feel free to put any question you have in the chat. And Carlos, if you want to also answer them afterwards, would be perfect. So following this presentation, Ksenia, would you be ready to share your screen?
First, just give me a second. I guess now it's visible.
Yeah, it's perfect. Thank you very much. The floor is yours.
Okay, well, it's really great that Carlos had this presentation before me because it's very complementary. I will talk about space metallurgy. So the first question would be, okay, sorry, my clicking is not working. Well, why we need the metallurgists in ISRU technologies or ISRU technologies? Well, Carlos already said what are the plans, the missions, and so on. And he also mentioned which metals we have on the moon. So you can, of course, see that we have a lot of water deposits, or at least we think that we have. But the majority of the surface, let's say, of the moon and the Mars is regolith. And those are the metallic oxides. And this is a potentially very big source for the oxygen production. And actually to produce it, we're using metallurgical extraction processes. And this is why the metallurgists are now involved in this story, let's say. So you have a production of the oxygen, but on the other side, as a byproduct, you have a metallic phase. So is it going to be a waste or useful material for us? So just to see. So that's maybe the question that we need to ask ourselves and to use it, of course, because we don't want to leave waste on the moon or the Mars behind us. So in that context, let's say the general strategic aspects for our institute or for the Earth and the metallurgical industry, like generally, is that we can very fast do the technology transfer of terrestrial know-how to space applications. And of course, we expect vice versa case. So what will bring to us that it's this harsh space planetary environment. So it will lead to improvements in terrestrial digitalization and artificial intelligence application in metallurgy. But also the zero emission and circular economy advancements. I will address these points in the next slides a bit more. So let's just shortly go what we're doing at the Institute. We have, let's say, 4 big research areas, which is recycling metallurgy, then materials processing, process design, and special processes. So all this work is done by 6 postdocs, as you can see, 27 scientific engineers, a lot of student workers, and we also have all possible workshops. So everything is in the house, analytics, mechanical, electrical, metallurgical workshops. So we can do the whole full job at once. So I will break it down and explain about, firstly, recycling metallurgy. So we do a lot of electronic scrap recycling to obtain copper, gold, germanium, and so on, these valuable metals. We also do battery recycling, which is now very hyped, let's say, and very important to obtain lithium, cobalt, and other metals, aluminium recycling, and so on. Why are we so unique, actually, in this area? It's because we're not doing just the lab scale research. We have actually the furnaces, as you can see on this photo on the right. We have actually the volumes of 1 cubic meter or 1,000 liter of the furnaces, metallurgical furnaces, microwave, very big, unique microwave reactors. So we can really jump from lab scale to semi-pilot or industrial. So that's why we have a lot of industrial projects and the Institute and very strong collaboration. But what this actually means for the space industry or what we can do with it. Well, my opinion is that we can maybe reuse or recycle the space debris that is left on the moon to produce metallic components or structural components. This is actually one of the projects that we had 2 years ago at the Institute. Because I don't know if it's familiar, but we have already over 70 spacecrafts, rovers, modules on the moon surface. So here are 2 articles that you can take a look what is actually left behind all these exploration missions. And as Carlos actually mentioned, there are so many planned in next year. So we're going to have a lot of, let's say, unuseful material for the space exploration, but maybe for production of some useful materials, we can use it. Let's jump to materials processing. As you know, if we want to do any building or constructions and so on, we're going to have very specific materials, very specific compositions. They have to be also homogeneous. So, and this control of the desired alloying elements and the unwanted impurities and so on, this is the task also, or the work that we're doing at the Institute. As you know, the regolith is composed of 10 metallic elements. So it's going to be a lot of work, let's say, to separate them or to find something that is really useful. The techniques that we're using in this area are, for example, fractional crystallization for obtaining very, very pure metals. For example, if we want to go for solar panels on the moon, the silicon has to have really high purity. We have also or some other metals that will be useful in that case. For example, vapor distillation, electroslag, remelting, also vacuum heat treatment we're doing at the Institute, which is, as you can see, very straightforward actually transfer of the environment that we can maybe find in outer space. So, but here is maybe the question to ask again ourselves and for the discussion later. Will material requirements be the same in the space as on the Earth? Are we going to develop some new materials and maybe develop new applications? That's something that we have to see. And of course, we are all here to learn that and maybe to explore. Shortly about process design. Of course, before we enter all this experimental work, let's say to reduce regolith to oxygen and the metal, we need to do a lot of thermochemical modeling, a lot of predictions, because if we don't do it, we can cause really big damage on the furnaces that are very expensive. We're talking about millions. Of course, the safety of personnel is endangered, and with it, the production delays are caused. And of course, if we do correctly, let's say, this modeling, we have a time, material, and energy savings, and we can also make a proof of our initial concept. Does it work or not? So actually here on the right, you can see one of the cases of the modeling of the reduction of regolith. Of course, I will not give for the moment the parameters, but you can really see, do I have the metal phase, do I have a slag, which is like the rest or the oxidic phase and so on. So you can definitely see what you're working with and what you're gonna get. And coming to this fourth or the last, let's say, big area at IME are the special processes at IME. I actually broke it down and named the current state of the art techniques for regolith processing. Why? Because mainly they're, as you can see, the reduction, either hydrogen or carbothermic reduction, and very important molten salt electrolysis. And this is exactly what we are specialized in at the Institute. So mainly now the research is focused on molten salt electrolysis, and maybe you have heard for the FFC process. Yeah, so, but the question will be, of course, which technique is or will be feasible and cost efficient. So this is also something to be investigated. A lot of work is in front of us in all these areas. We're really downstream now, but I think it is indeed time to start with it. So where we can also identify the symbiosis of, on the Earth, let's say, needed metallurgical improvements is indeed molten salt electrolysis. And I'm also happy to, let's say, announce that we are entering a big project with aluminium producer in Europe that are going out of the, let's say, CO2 emission, and they're switching to the inert anode. It means the oxygen will be, as let's say, emitted as a gas and not CO2 anymore. And this is exactly what we're doing for the regolith. With that, I will try to simplify what is actually the molten salt electrolysis. So let's say you have a molten electrolyte, you have a salt that is heated up, it is in molten state. You're putting in the regolith, which is this mixture of the metallic oxides. And with the help of the current, you're splitting the regolith onto oxygen that is involving at the anode. And on the cathode, you have a deposition of the alloy or the metal. So those are two main products of this process. There are, of course, difficulties with this process. It is not that simple. Just put the current and you have the magic. So there are a lot of parameters to be followed and to be controlled. I think that I will get deep into it if I'm talking now about it. So let's go further. What is important that we are doing this research for over 10 years at our institute. And as also Carlos mentioned, that the rare earth elements are very important. And this is also, let's say, one of the projects I worked on in previous years. And this setup that you can see actually is indeed for the rare earth production. So we have the fully automated process. You have the rectifier that you cannot see on this picture that is supplying the current into the cell, and it is everything connected with the off-gas detection, so we can measure which gases are coming out of the process. We have the process controller, controls all the parameters and triggers the feeding of the oxides, let's say in this case regolith, into the cell, so that you can have your oxygen production and metal as well. Also, one of the special processes that I have mentioned on the other side is metallothermic reduction. This is one very interesting, let's say, method technique, because you can reduce the oxidic, fluoridic, or fluoridic metal compound by a noble metal. And the beauty is that it is exothermic reduction, and it's self-starting after initial ignition. So you don't have to, let's say, have the energy input. It's just doing by itself. So because I don't want also to go deep into it, if you go to our LinkedIn page, it's IME process metallurgy and metal recycling. There is a very nice short video about this, this technique. And I would like to mention that I think it was in February or March, when it was Luxembourg Space Resources Week, that we actually presented jointly 3 institutes of RWTH Aachen. It means IMT, which is Advanced Mining Technology, then AMR, which is Mineral Processing Institute, and IME, Metallurgical Institute. The whole process chain for the production of the oxygen and the structural materials. So we have the mining, Advanced Mining Technology Institute, that is, let's say, searching for the regolith specific composition, for example, to detect ilmenite, which is the iron titanium-based oxide. Then we have the Mineral Processing Institute, that will do the concentration of this regolith or the mixture, because as I mentioned, regolith is a mixture of 10 compounds, and it is very difficult from this compound to create something useful. So we indeed need to be very selective in this case. And when they concentrate the minerals, they're coming in the molten salt electrolysis, where we have the oxygen, and with one, in our case, further step, maybe structural materials that we can use for the habitats. Yes, so that's us. And in that case, we have developed one of the first zero-waste concepts that we call Musari. So as I said, when we have the regolith, if it's beneficiated or not, definitely depends what we're going to get from the mineral processing people or the mining. So it enters the electrolysis in fluoride-based electrolyte. I have mentioned previously the FFC process as state-of-the-art. This is made in fluoride-based electrolytes. We switched for the fluoride base because we have a lot of experience, as I mentioned, with them in the case of rare earth elements, and they also have the benefits of the lower vapor pressure than fluorides. We also have a direct separation of product from the electrolyte, of course, without prevention of material loss. So, and of course, from this process, we are getting the oxygen and a master alloy. So, but the next step is, because we have this mixture of the metals or this alloy, so we need to be a bit selective. It enters this, as I mentioned, nice self-ignition, let's say, or exothermic reduction process to upgrade this master alloy. So we have a selective reduction of only iron, titanium, and probably silicon alloy. And the beauty of this is that everything that is kind of a waste from this project, from this process or this step, this oxidic product can be returned into electrolysis cell. So we have a closed loop, and then we deposit again, let's say, this material. And on the other side, it can also be used as construction material or for 3D printing and so on. So with these two steps, let's say we have closed the loop and we have created already the zero waste process. You can see here the schematic depiction of this, and this is patented, or patent is registered. So let's see what comes in the next years with exploration. Okay, I would like to also now finish my presentation. I don't know how many minutes I had, maybe I overreached it, but it's fine. So the mining, mineral, and metallurgical processing play an important role for the ISRU establishment. I think that we have seen now nowadays creation of the new roles. I think that actually you had at the beginning also this questionnaire, what is your role or what you're doing? So maybe on the next year on a meeting, you can maybe say I'm a space metallurgist or a space miner or something like that. So you can help me to create completely the new name for this role. Yeah, furthermore, transfer of circular economy activities to space sector should be already considered, as I said, because we already have a lot of waste, so we should not allow it to go further. So with that, we have a necessity of design, use, recycle approach. As I mentioned, because of those technical challenges that we're facing and economic benefits that will bring the innovations and changes in metallurgy. So that's something to expect definitely in next years. Also, we have seen the symbiosis of the terrestrial and the space techniques on the inert anode, which will help to do the decarbonization efforts and to maybe fulfill the Paris Agreement in 2050. Let's see. Improvements in digitalization and application of artificial intelligence in metallurgy will be also in a big extent seen. And we definitely, what we are doing here now as well, with this webinar and all the meetings, we need to have a stronger and complementary collaboration between different sectors. And I think it's going to happen also in the next period. So I want to thank you for your attention. And of course, if you have a question you can ask. I hope I didn't went too detailed or too technical. Yeah, so thank you.
Thank you very much. Yeah, it's very interesting, a very complete presentation. I think very complementary as well to what Carlos presented before, and provides a deep dive, I think, into the processing part of SRU. So really feel free to have any question that we will relay. So from the chat, there's a Q&A session afterwards. I know that some of our speakers may have to leave after 8:15, so we will relay anyway these questions. And after this, so now we understand really the goal also of going back to the moon and staying to explore. But how we will do that? Well, now Miguel Mendes will present us a bit more about how rovers and robotics can support these activities. Miguel, if it's good, the floor is yours.
Thank you very much. Excellent. So give me a second. You should be able to see the presentation now. You see it, yeah? The right one.
Perfect.
Okay, great. Okay, so thank you very much. So it's a pleasure, as mentioned before, to be here explaining a little bit more what we are doing on a Space Robotics Research Group. That was perfect, where I know a little bit the work of Carlos in Icepace, but also the very interesting work on Senja. So I will be able to continue, yeah, with this great topic, yeah. So we want the resources. We want to do something with that resources. We are not going to go there, astronauts, to be like miners there. So we need robots. So already Carlos mentioned the big amount of mission that are expected to be launched in the next years. But also these companies, yeah, they will need experts to have been doing the PhD on space robotics, for example, yeah, and here we are. So, okay, so Space Robotics Group is a quite young group. So I founded in the 1st of January 2020. We try to make it smarter, yeah, the robots. But even if it's space robotics, I'm coming from aerial robotics, as mentioned before. And I still have many projects on aerial robotics. And then we are focusing on aerial and ground robots, but also on planetary robots and also on orbital robotics. Okay. So as mentioned, we founded I founded well, 1st of January was one single person group. I got 12 projects from 13 submitted projects, so quite successful. We already have 2 industrial partnerships. We acquired more than 3 million in competitive funding in 1.5 years. And we are now reaching 20 researchers in between researchers, technicians, and master students. Furthermore, we have 2 state-of-the-art facilities that I personally designed and set up. So we are making a smart. What is making a smart robots? That is allowing them to understand the environment, to navigate on this environment, and to interact with this environment. Okay, not only with the environment, we also want the robot to interact one with other robots, and doing some multi-robot intelligent decision making, smart task allocation, efficient collaborative strategies. And yeah, we want to go for these resources on the moon. We want to find them and to collect them. Yeah. We can also consider that satellites or other things that are on orbit could be also resources, but that will bring to another webinar, another event. Yeah. So let's go with the research group. So as mentioned, almost 20 people. We are more or less same amount of postdocs, PhD, and master students. We, for example, have a master student from the university in France doing the master thesis with us. And we are open to have intern for doing the master or other type of visits. Yeah. These are some of the interesting topic or expertise that we have with the different postdoc that we are in the research group. So we focus on autonomous navigation, of course, so all these sensor fusion, object detection, recognition, trajectory planning, and following. The control at different levels. So not only fully autonomous, of course, fully autonomous is the goal, but we need also to go step by step. coming from telerobotics to assisted, semi-autonomous, and fully robots. In order to interact with the environment, we need manipulation, so work together with other robots or grasping things, multi-robot cooperation, and of course work in machine learning for robotics, not only on computer vision, but also on other sensors, control, and we are also doing super resolution for remote sensing. These are some of the projects that we have granted this year. So as mentioned, coming from aerial robotics, my group have also many projects on aerial robotics, planetary robotics, to work on multi-cooperation of robots by using fintech and regtech technologies, so basically blockchain technologies. That's by the way, open position for a PhD. I will let you know the open position that we have in the lab later. We have projects with orbital robotics, and we have industrial partnerships. We offer industrial PhDs position, working more or less half of the time in these companies and half of the time in the research group. Let me show you the lab we have designed and constructed. So this is the Lunar analog facility. This has been done in fact with the support of people from Icepace. So Abigail Calzada and also Philip Ludovic, who helped me on the selection and designing and later on the setup. So you can see we have 80 square meters. We fill it with 20 tons of basalt. This is a closed room in order to don't have light coming from other sources, and to simulate also the sky on the moon that is completely black. We have different type of robots with and without robotic arm for doing the cooperation, for doing the actuation and the control of the robotic arm. And we have now a setup of rocks in order to simulate different landscapes. Yeah, we have installed a motion capture system. For those who don't know about it, this is a system that allows us to validate and evaluate all the algorithms that we develop, not only on perception but also on control, trajectory planning, and in this grasping, for example. Yeah. Another facility that we are just finalizing to construct is the Syroge Lab. This to simulate on orbit scenarios. I'm not going to go too much on the details here, but that's also a very interesting facility that will go on the interdisciplinary space master later in order to show you that you can use this lab when you are doing the master here. So what the basic of this lab is that we have a perfectly flat flow. We design these floating platforms. These platforms are equipped with a pressure button or constant air supply, and they are blowing air against the flow. So they are simulating, they are removing the friction between the flow and the platform, and we simulate 0G gravity on the X and Y, yeah? So on the same plane of the flow. Then we have other robotic arm in order to simulate different kind of orbital scenarios, and that is also this facility can be used to simulate the 1/6 of the gravity of the moon. Yeah. So if we want to have a robot that is not only crawling or rolling but jumping, we can also simulate the reaction of a jump here, because this floating platform are equipped with thrusters, so that can move and create zero gravity, but also less gravity, so more gravity. So we can simulate here also this kind of hybrid system for exploring the moon. And now I would like to go on explain you a little bit more about the interdisciplinary space master. This is a new master that is already next September is going to be the third cohort starting, and it's still open for European, by the way, for European applicants. So the idea of this master that was initiated and supported by Luxembourg Space Agency and was launched in September 2019 by the University of Luxembourg and the Research Center, the S&T, the Interdisciplinary Center of Security, Reliability and Trust. Well, the idea of this master is, as the first word is mentioned, interdisciplinary. So contrary with other masters in the rest of Europe, but also in US, that focus on the engineering part or other specific parts of the needs on space. Here we go on the interdisciplinary. And this is aligned with the next event in Lille. This is aligned that non-space companies will be participating in space, and non-space people will be participating in space. Yeah, so we need very different backgrounds for space companies coming from. And here you can learn some of these topics. So you can learn space entrepreneurship, space engineering, of course, robotics, informatics, but also business, finance, and law. Yeah, what is all these legal issues that are going to happen when you grasp a rock on the moon? Yeah. So here we want to cover all these things. We have professors from the University of Luxembourg, of course, but also from experts from abroad. We also invite people from the companies here in Luxembourg, like people from Icepace or other companies, to give talks, and this is quite very connected with the full space ecosystem here in Luxembourg. Yeah. So just a little bit of the admission requirements. So as you see, it's quite generic, the profile. So physics, mathematics, mechanical, any type of engineering, computer science, even natural science or equivalent experience. Yeah. The idea is that the master is teaching in English completely, so it's required B2 in English. But I guess for all the attendance, it's not an issue at all. So and what this master can provide you. So this master can provide you technical employment in different new space companies, also to create your own new space company, work on LSA or other space agencies, and also doing your PhD. Why not? Yeah, not only on robotics, but also in other research group that we have in S&T or out of Luxembourg, our space robotics, communication, observation, computer vision, etc. Here you can see a little bit of what are the modules that we have. So we have expert on resources, from the University of Colorado, Professor Angela Madrid. We have, me and my group are teaching the robotics module. If you see in LinkedIn, so try to find me, the student publishing the last experiment they are doing for the final project of this semester. They constructed, assembled a rover for the moon. They installed software, sensors, and now they are making this robot to go independently, autonomously to search resources. Of course, the resources are quite easier to find or to distinguish, but this is still a very interesting thing. Yeah. So also on application, satellite communication, guided navigation and control, GNSS, ICT, and so the entrepreneurship, business, and legal part. Yeah. These are the facilities. So two of them, you already know it because I presented before. We have also a CubeSat lab. This is, for example, a nano-avionic 3-module CubeSat that you can launch because it's fully equipped. We have a concurrent design facility to do concurrent engineering, mission design, mission monitoring, and also a satellite communication lab, yeah, to emulate different kind of delay with the connections with orbit, or for example with connection to the moon, yeah, as we are doing in one specific project. Also, this is a project-based learning. We have some connection with ESA, where we are doing in the third semester 3 different missions, so analyzing these specific missions and redesign them to respect of the space resources. Yeah, and these are supervised and mentored by 3 former ESA program managers who were involved in these specific missions. And then the final report is presented in the Space Resource Week in Luxembourg. Okay, so I'm reaching my 15 minutes, and I just want to finish saying that we are hiring. We have 4 PhD positions open. We want you to science, yeah, and later to go to companies as cool as Icepace or other companies here in Luxembourg or out of Luxembourg. So you have my email here. Don't hesitate to contact me if you are interested in any of these positions. Thank you very much, and that is all from my side.
Thank you very much, Miguel. Very interesting as well, and I think many people are quite interested in all these positions. So I'm pretty sure you will get lots of applicants, and for sure, if the people here have the chance to meet you in person in Lille in 10 days, that will be also a good chance to know more about this opportunity.
Absolutely, absolutely. We can discuss further. Thank you very much.
Thank you, Miguel. And as our last speaker, we have Romain Charles, which will be presenting spaceship. So going a step forward after using robotics and extracting these resources, what are we going to do with them or along the way? This is up to you.
This is a big question. Okay, can you see me? Can you hear me?
All clear. Perfect.
All clear. Great. Well, I feel lucky to be the last to talk because I could hear a lot of keywords that will come up during my presentation. I will try to keep it short so that we can have some time for questions. So I will talk about the Spaceship FR initiative. And actually, to start talking about Spaceship FR, I have to start a bit further, talking about the Spaceships network, which was created by ESA. And the first of all, the Spaceships was the Spaceship EAC in Cologne at the European Astronaut Center. I had the chance to see it grow. It was created in 2012 and now is quite strong. I'm pretty sure a lot of you know the Spaceship EAC team lead, Aidan Colley. But then after Spaceship EAC was Spaceship XSAT, and the third one is Spaceship FR. So all those spaceships are under the umbrella of the expert program of ESA. So those are just a few words. Now each spaceship has its specificity, and each spaceship share a common ground, I would say. One of these aspects which is common between all the spaceships is the students, like having a lot of students participating in those projects, bringing new ideas and being able to tackle all the problems of space exploration. So now going back to Spaceship FR, what is the main target for Spaceship FR? So our ambition for Spaceship FR is to prepare the future of exploration. So we try to imagine Spaceship FR on a celestial body, on the moon, on Mars. What are the technologies that are needed to survive and thrive on these celestial bodies? So to do that, well, we look for what is existing, and we just follow the lead of all the experts who gathered around the world. So ISECG, I heard that, I think it was from Ksenia, who talked about the global exploration roadmap. So thank you for introducing that. The CNES, Centre National d'Études Spatiales, the Space French agency, looked at all the global exploration roadmap technologies, technology gaps, as they call it. And out of the 47, they decided that 25-ish of those were important. So we had to work on those ones to prepare the future exploration. And they gave that to Spaceship FR. So it's quite a broad endeavor, for Spaceship FR. So we try to understand what are the different topics. So already we looked at how to reduce this big amount of technology gaps into more understandable, we call that technology areas. So on those 6 technology areas, already Miguel talked about automation and robotics. Ksenia talked about in situ resource utilization. Actually, I think, and I'm sorry, I forgot your first name, Olive. The first speaker, I'm sorry about forgetting your first name. Talked about all that. So the few other things, structure and shielding, life support, crew health and performance, and energy and power distribution, those are important parts. We are looking into those, but I will come back to that. So we started with that. This is the basis of our work for Spaceship FR. Now, we had our ambition. Now, on the Earth, what is our ambition? Our ambition is to have a Spaceship FR building, which would be some kind of demonstrator that the technologies that are developed here in Toulouse, but also in other places like Icepace, like in the Luxembourg Space Agency, that they can work together. So it's really trying to cooperate with the different actors on those ones. And this, for the ones who can recognize this picture, this is the Centre Spatial de Toulouse, so the CST in Toulouse, and the building on the left that you can see, I don't know if I can show it, this one is where you have the CADMOS, which is the control center for a lot of physiological experiments with the ISS. So our ambition is to have a building where we can demonstrate that the technologies developed work together, so that we can be there, we can move on, we can be present when we go towards the Moon and Mars. Spaceship FR is turning around a motto, 3 words that we try to embody. Those 3 words are inspire. The first one is inspire. It is through outreach, talking about space exploration, but also through the education of all the students and postdoc, all the people who go through the Spaceship FR, just like it is done in the other spaceships. The second word, which is very important for us, is to federate. Federate meaning we want to create a community of like-minded industry, academy, universities, and startups, agencies. So we try to have around us the people who have ideas and who have the energy to move forward. And the fun fact or the interesting fact is that a lot of those actors or a lot of those companies and startups are not really coming from the space world. Most of them are actually, but some of them are not. So it's really trying to find the people with the right skill set to help and enhance and push forward the technologies needed for space exploration. The last of the 3 words for our motto is to support. And I think this is the most important slide for this presentation. It's what happens and what happened so far. So here on the left, you have some of the tools, I would call them tools, that we use to develop those new technologies, some of the projects that we are working on. And on the right, you have the companies with whom we work on those ones. And the first one, the greenhouse feasibility study, I think is very interesting because Agricool, not so many people know about them. They do urban agriculture, I would call. And to do that, so they have like 80 containers in Paris, but to make sure that they control, that they can manage their process, their container are sealed and without windows, and everything is injected and followed very closely to have the best process possible, which is giving the best outcome regarding both the quantity of plants and the quality of plants. The nutritional facts of those plants is followed too. So looking and reaching out to these kind of companies is one of the important, is at the core of this spaceship FR. So research and technologies is just trying to inject some money in technology that we think could be useful in space exploration. School projects is also a bit part of Inspire, the Inspire DNA of the spaceship FR. Partnerships. So for this one, we have a bioreactor with this with INSA in RAE, which is a laboratory in an engineering school in France, looking at how to break the molecules of the yellow and black water into more processable, into molecules that can be processed more easily by plants. We not define exactly what is yellow and black water. I'm sure most of you understand where it comes from. So we are moving forward. The last one could be interesting too, if you want to talk about that. The ILOTS habitat, the International Lunar Surface Transportable Shelter, which is, we are working on it on the Spaceship FR side, but Spaceship ESC is working on it too. So yeah, trying to really cooperate all together is something quite important for us. I don't want to go too deep into those. I will wait for your questions if you want to talk about some specific projects. I try to give you an introduction, as it was said at the beginning. And I just thank you for your time and your attention. And I'm ready to take all your questions. And if you have questions, if you want to send an email, you have my email address at the bottom too.
Thank you very much, Romain. Very, very cool as well to see all this initiative, not only in Cologne, in the UK, but also now in Toulouse. And I think that's really closing the loop and bridging, connecting a lot of the efforts which are done. So I'm really glad from all your presentations. Thanks again for sharing your insights. And I'm very looking forward to the discussion in live in Lille. We have a couple of questions actually. First question, maybe for Carlos. Is there an international dedicated protocol to protect lunar HO2 from Earth microorganisms coming with the landers? I will put the question in the chat.
Right. I don't think there is a protocol as yet as to protect water from, well, there is in a way, there is in the International Space Treaty in terms of, and maybe Antoine can help me here, in terms of not bringing, you know, living bacteria and other elements from Earth to planets like Mars and the Moon. So there is in the International Space Treaty. And of course, we will be abiding to all those rules. But specifically to H2O, I'm not completely sure. Yeah.
I'm not aware of H2O, but there are some protection contamination standards which are more or less severe, especially for Mars. It's quite severe. Maybe one of our speakers can comment on this. Well, that's to be searched then. That's to be searched and discussed in Lille. But I think it's mostly for Mars, where we think we can find life, and on the Moon it's not the case so far. Okay, so one question for Ksenia: how reuse of space debris left on the Moon? How to reuse space debris left on the Moon? Is it by melting materials with a machine to produce metallic components?
Hi, yeah, good question. I'm thinking how to answer it, honestly, because we have so many confidential agreements signed. So I cannot go deep into indicating how to do or what to do with space debris, but why not? I mean, you have so much of pure metal components, a lot of debris. Why not melt it and produce something that can be useful? it's the easiest way. Start from it, and then you're going to go deeper and deeper, I'm quite sure.
That's also interesting because on the moon, we're talking about the fact that there are robots, landers left on the moon, but they are, I guess, very scattered, not gathered in the same place. So maybe when we will have more activity with the Artemis camp or the ALRS, there will be maybe more concentration of metals.
For sure.
So one question we have also for Romain. Romain, how do you see these projects going from R&D, from a university or projects, or from research projects to payloads which will fly at some point on the moon, or as yes, future technologies to fly on the moon?
So that's a very good question. And actually at CNES, there are a set of groups that help push technology through all the different TRL levels, so the technical readiness levels. The Spaceship FR is quite at the beginning, so trying ideas, new ideas, and failing, that's part of it, and it's okay. When you go above, then failure is less of an option, but there is some another group called Connect by CNES, which is putting together investors and startups and bigger companies. So really trying to push the technology to the next level and to be able to produce and to use it, and always trying to keep an eye on, yes, it is for space exploration. There is an interest for CNES, but they usually like to push technologies that are also have an application on Earth, that can help on Earth through the sustainability, recycling, health, all those things.
Okay, thanks. And as you say, there is a complementary suite of tools like CNES to go to different markets, different maturities. Okay, one other question we have actually for Miguel. What can space robotics learn from terrestrial robotics? What is a thing maybe that terrestrial robotics are doing way better than in space?
So that's a very good question. So we can learn a lot, yeah? So that's the point. I'm coming from Earth robotics to space robotics. We need to, we have been working on a lot of AI algorithms to develop for Earth robotics, and that can be, of course, with some adaptation, extended to planetary robotics. But also, what is also very important on any space activity is to have also some similar activity on Earth in order to make more use of this technology, and also for the companies to make a most efficient business, yeah, so more important business. So that's we can learn a lot. Of course, the situation is a little bit, it's very different over there, but yeah, the idea is using this kind of facilities as the one that Icepace have in Luxembourg, the one that we have in Luxembourg, and other so Romain have going to construct in Toulouse, to have a step between Earth and planetary robotics, but mining on Earth and mining on space, that will be handled by robotics in the future for sure, and many things can be extrapolated in one way or another.
All right, thank you very much for this answer. Maybe does anyone has a question that they would like to ask? Like, feel free to put your mic on, or actually we have one last question maybe. And yes, it is, do you see the need for in situ pre-deployed localization systems on the lunar surface? Maybe, well, I think anyone can have an opinion.
I can just say a few words. in the slide I was presenting, there is the last project, which is ELOTS from Spartan Space, and this is an interesting concept of a lunar habitat, which is really reduced, and that would be pre-deployed as a safe haven or a shelter, or as a way to explore further for human for the astronauts. So just like when you go on the mountain trails, you have some refuge. It would be a bit like that, this idea. So it would be pre-deployed, and we are trying to move towards that with this startup.
Interesting, very interesting. Looking forward to follow the steps. Do you know if maybe this is can be followed online in your spaceship account, or?
Well, there is a there is a web page for Spartan Space, but I don't think they share yet a lot of information on it, as it is still in the early stages of this startup. But I'm pretty sure you will hear about it quite soon.
Nice, so to be followed up. Nice. Well, thank you very much for everyone. I don't know if there's one last question, maybe. And
I think that Carlos had a question for me.
Yes.
Please go.
Yes, I do have a question, if that's okay.
Of course.
It will not be that long. So first of all, Sinia, thanks a lot for the presentation, and it's just really exciting to see that there are now centers and groups working intensively and doing really amazing work on the area of mineral processing, metallurgy, and so on. So that's absolutely awesome. Now we, let's say, mine planners, when we need to build this, what are they called? Well, just mine plans, right? One of the most important parameters that we need to incorporate is recoveries, right? So in the concept of zero waste, which is around the Mosari project that you guys have, or circular economy, does that mean that we will at some point achieve 100% recoveries, or we will still have some loss of the element of interest? I guess it depends, but
yeah, certainly. Let's say you will have different phases. You will have also operation of some elements in the gas phase and maybe electrolyte. Then you will have the liquid phase and the solid and so on. So that is, of course, our idea is to use all of it somehow. Everything has to be captured, stored, and then in a way reused. So of course we are aiming the 100%. In reality, on Earth at least, it is not always like that. But this is something that maybe indeed the space activity will learn us to do, because on the Earth we don't really care, because those are byproducts that we don't think we can reuse or something. But that's why is in situ resource utilization important, because we want to use everything possible that is there, no waste. So I cannot say for the moment that with certainty that we're gonna have 100%, let's say, use, but this is that, at least from the conceptual idea, from the first, let's say, calculations, and now we're starting also the experimental part, we will, with many iterations, see if that's feasible or not. But definitely the aim.
Awesome. Thanks a lot, Sinia. Thanks for
You're
that.
welcome.
Well, I think we are coming to the end of the webinar. Thanks again for everyone for attending, to the speakers, to the organizing team. And we are a bit late. I'm sorry about this, but I see there is a big interest, lots of discussion, and really looking forward to continue that together indeed on July 3rd. So thank you very much, everyone, and have a nice evening, and see you soon.